Dimensional analysis. What are we analyzing? Excuse me. Excuse me. What are we analyzing? Dimensions. Now, unfortunately, I'm not sure about your teacher, but your teacher may not even discuss the word dimension. And that's a problem. Okay. Now, your teacher will definitely talk about units, but units are not the same as dimension. Okay. So I want to make sure we address this first and foremost at the very beginning of our discussion. What is a dimension? Have you heard of 3D? What's 3D? And what are the three dimensions when we say 3D? You know? Well, when we say 3D, right, it's an object. You can see like, wow, it's showing in front of you. And to talk about an object like this, how do you find out the volume? Length, width, and height. And that's your 3 dimensions, right? But for us, we actually just focus on one simple dimension. That's called length. So that is called a dimension. Now, in terms of this dimension, we can have many different kinds of units. We can have inches, we can have yard, we can have feet, right? We can have centimeters, meters, kilometers, and so forth. We have so many different units for length, but it's still a dimension of length. Okay? We can also have time. Time is also a dimension on its own. Have you heard of the 4th dimension? No? That's time. And the units for time would be seconds, minutes, hours, right? Days, so forth. Many units. Okay? What else? What else for time? What other units do we have? Now, what I realized is that since it's chemistry, so your teacher may not be very physics aware, so they somehow lump mass and weight together, which is not the same thing in physics. Weight is weight, mass is mass. When you go to space, your weight is changed, but your mass stays the same. But whatever. Okay, you will see what I mean later on with the example problem. So what's mass and weight? You can have kilograms, you can have pounds, okay, you can have ounces. Okay, so these are the units. You can also have grams, of course. After kilograms, you can have grams. Okay. Good. Anything else? Anything else? Now, there are some other dimensions or some quantities that are a combination of multiple dimensions. Like, for example, have you heard of density in previous science courses? How do you calculate density? Mass over volume. Like, hey, there are the 2 dimensions, mass over volume. Okay? And so we have units of grams per milliliter or grams per liter, okay? And so forth. And because of the volume, I forgot to mention the other dimension called volume. We have milliliters, liters, and by the way, do you know that 1 milliliter is the same as 1 cubic centimeters? If you don't know, you will know. You better know it now. Okay? So that's the difference between dimensions and units. All right, there are 2 different things. You can use the units to tell what dimension it is. Great. Okay, that's great. So if you look at your worksheet number 4, question number 1, okay, it says, hey, could you go ahead and convert 5 kilograms to ounces? So this one is just change of units. There's no change in dimension because kilograms is mass or weight, and ounces is still mass or weight. But now, how do we figure this one out? Now, if I may, I want to take some time to explain this from an Algebra 1 level first, and then I will transition you to your current level. Well, how do we go from kilograms to ounces? Well, if you look at the top of this page, there are some so-called equalities, right? They're right here. And they would help you out. But now, what I want to emphasize here is, where do we see kilograms? Do we see kilograms? We don't see kilograms, but we do see grams. And gram is related to pound, pound is related to ounces. Okay? So what is pretty crucial is that before you start, you can map out the route, such as kilograms to grams, grams to pounds, pounds to ounce. That's the route. And one more narrative that's also very important is that if you know kilograms, then you should know grams. Because, now it's not listed here and we expect everyone to know this. Because you know you should know the prefix K, that's for 1,000. So 1 kilogram is to 1,000 grams. Okay, so if you know kilograms, then you should know grams. And if you know grams, you should use this to know pounds. But now, let me start over from the algebra one way. So I can say, hey, x over 5 kilograms is to 1,000 grams to 1 kilogram, right? Do you remember ratio back in algebra 1? Now, can you do this for chemistry? Yes, you could, but definitely not recommended. And let me tell you why it is not recommended. It is not recommended for this reason, because you're going to find out the answer one at a time, and it's going to take you so much more time unnecessarily. So what do we do? Well, now, are you okay to go from here to here? We multiply by 5 kilograms on both sides. And for a particular reason, I put 5 kilograms to the left-hand side of the fraction, but not to the right-hand side of the fraction. Are we good? Yes? Now, if you can see this manipulation, then you can also see how the kilograms will get canceled out. It will get canceled out. And what's the unit left? It's grams. So this calculation will give you the number of grams, which is 5,000 grams. Pretty obvious, right? Now, what's going to happen is this. In chemistry or high school chemistry, we would say, hey, let's go ahead and convert kilograms to grams. Good. Let's go ahead and convert grams to pounds. Well, we have our relationship right there. 1 pound is to 454 grams. But how do we put it as a fraction? It's an equality. Well, the same kind of understanding. That's why your teacher would say, hey, just look at the units. They should cancel each other out diagonally. Why? Well, when we did ratio back in Algebra 1, that was it. So you just carry out all these so-called ratio calculations subsequently. And then what? Pounds to ounces. So we say 1 pound is to 16 ounces. So that's the setup, all right? It's just ratios back in Algebra 1, but instead of finding one answer at a time, we just lump those together in one long, giant calculation like this. Okay? Now, before we calculate the answer, I would like to address one more thing. Now, this is something that I don't like, and I have a reason to not like. Your teacher would probably do this. And I am not going to do this in front of you because I have had students telling me this, that when they see their teacher showing this table, or they call the railroad track, they did not realize that it is just multiplication of fractions. They thought it's just some kind of made-up procedures to arrange numbers, and they just replicate the procedures because the teacher told them so. And to me, this table is not really offering anything more convenient than this multiplication of fractions. So you will see me doing this, but when you go back to school, to please your teacher, you will do this, okay? Just to please your teacher. But you know it's just multiplying fractions. And these fractions, and the other thing about these fractions, the numerator is always equivalent to the denominator. Okay, I use the word equivalent because you're going to see how it's being applied in a broader term. For now, they are exactly equal. 1,000 grams is to 1 kilograms. Now, let me go ahead and give you a wrong illustration. Let's just say you're rushing and you somehow flip the wrong fractions. How would you know that you're wrong? Well, some students, if they don't know much about math, they would try to cancel these two out. And I'll be like, wait, what? What's kilograms times kilograms? That's kilograms squared. They don't cancel each other out. They only cancel each other out if they are dividing each other. And you can look at these two, they are not the same. You cannot cancel them out, period. And that's how you recognize that, hey, something is wrong right here. All right, now, use your calculator. Can you compute the final answer right here to give you a final answer of ounce? Okay. So now the way I like to do this, there are two ways you can do this. Some teachers would say, all right, go ahead and multiply all the numerators together and then divide by the denominator. It works with one possible problem. Like in this case, you have only one number that's not 1. Okay, it's 454 in the denominator, so you're dividing by just one number, which is fine. But if you have multiple numbers that are not 1 in the denominators, then it could cause a problem because you need to use parentheses. So for me, what I would recommend you is to do this. Just take care of one fraction at a time. Times 1,000 divided by 454 and then times 16. You can just type this into your calculator chronologically from left to right, and you should get 176. And 176 will be your final answer because the number to begin with had 3 sig figs. So your conversion should not have more sig figs or fewer sig figs than the given. So that's the significant figures side of things on dimensional analysis.